Hi, everyone. It is great to see you all here today. Thank you so much for coming. This is our final week of the Teach with Chrome series, and today's session is on coding on Chromebooks with CS First, and we'll go ahead and get our slides up there. We've got a great lineup of resources to share with you today. And I am Donna Toiber. I am a Google for Education certified trainer and innovator, as well as a coach. And I've been working in K-12 for many years, and coding is a special treat for me. I really love to talk about the subject, and I'm excited today to be here with Tim Swick. So I'd like to ask Dr. Tim Swick to share about himself, and then we'll get started with our session. And if we could have our slides up, that'd be, there we go.
There we go. So, yes, I'm Dr. Tim Swick, and I'm the lead teacher of a public elementary school in Columbia, South Carolina. We are Sandlapper Elementary, and I work in our magnet school, our computer science immersion school. So I work with K through fifth grade public students, and we work on integrating computer science into our subject areas. So that is my kind of experience with computer science.
Thank you. And he is an expert. I just wanted to say I've worked with Tim on a number of innovation projects, and he always knows all the right answers when I have questions about coding. So also thank you to the Google for Education team for having us here today, as well as Kiker Learning. And here's our agenda. We are going to just launch coding with CS First. We're going to explore what CS First is and give you some resources, show you how the dashboard works. And then we will launch out into looking at coding using other platforms. So Tim's an expert on those platforms, so we'll take a deep dive into some platforms you might want to use. And all of these resources work on your Chromebooks. And then we'll close with a Q&A and look for additional resources. And I will be monitoring chat, so if we see some questions as we go through that we can answer as we're presenting, we'll definitely do that. And we'll allow time at the end for that Q&A. And with that, we're going to get into why coding. And my answer to why coding is that coding answers many questions. When we have these big ideas, how do we want to solve something? Technology is a way to do that. And coding allows us to make things happen. It's all about problem solving. And so as we look at these concepts, our students are learning logic. They're learning how to make judgments. They're making steps and rules. And we do that in English class as well as in science and math classes and social studies. We break things down into parts and then removing that unnecessary detail, getting down to the basics of what works. So there are a lot of great activities that we'll tell you about for that. And then it's also about mindsets, giving our students the ability to persevere. Perseverance is so important, especially as our students think about what's next when they get out of school. What kinds of college will they go to? What careers will they go into? But perseverance is something we've all experienced over the last few years. I think we've all been persevering. And resilience, being able to bounce back, to learn from failure, to be creative, and to collaborate, to be collaborative. So these are all mindsets and problem-solving skills that coding supports, and that's why we're here today. And I'll let Tim tell you a little bit about the career aspect.
So in addition to the things such as problem solving and having a mindset of perseverance, resilience, and then creativity and collaboration, another real reason to encourage students to study and learn as much computer science as possible is we know that this is a field that is going to grow tremendously. Looking at the United States Bureau of Labor and Statistics studies, they know that there's going to be about a 22% growth in just the next 10 years. And because of this growth, we also know that there's going to be a significant job gap where there will be a number of jobs that might not go filled with qualified candidates unless we start preparing students for that future now. So we know that with emerging fields such as artificial intelligence, virtual reality, as well as data research, we know that there's going to be a rapid growth in these areas. So starting students, as in our specific case at our school, as young as kindergarten, to start looking at ways to solve problems with coding and to start studying computer science at an early age to generate that interest. We know that having that background should hopefully benefit them for the growth of these jobs in the future, and also the fact that they'll be really good, high paying jobs as well, we hope. And then I would add one other benefit of coding that we don't have listed on this slide is we know kids enjoy it. It's something that they have a lot of fun with. So in my role particularly, I always look forward to teaching coding because the students, it's something that they want. It's something that they are interested in. And it really makes teaching easy when students are interested in what you're doing. So now just a little bit about a focus on how to integrate, or why integration is a key component of computer science instruction. And in my background at our school, we are a computer science immersion school. And the way we've organized computer science education in our program is that it's not something that happens in a special place in the school. All of our teachers are receiving professional development and training, and we're focusing on how to give our classroom teachers the skills that they need to feel confident in integrating or including computer science instruction in their classrooms. And the way we hope to achieve that is by focusing on something known as computational thinking. This is a skill that is cross-curricular. It's specific to computer science, but allows you to focus on ways to integrate computer science outside of just specific computer science oriented or traditional fields. So it's how we integrate coding into different subject areas. Now, there are core components to computational thinking that we focus on, and those components are broken down into different principles. And the principles that we look at with computational thinking are giving students strategies and activities to help them with things like decomposition, pattern recognition, abstraction, and algorithmic design. And coding often is a platform for bringing computational thinking activities towards our students. So sometimes I like to explain when I talk to people why we feel coding and integration is so important. Coding is really just one small aspect of computer science, which is this big field. But then if you look at computational thinking, it's even larger than just the field of computer science. It's looking and focusing on broader problem solving skills. So at our school, we don't just say we're training students for careers in computer science. We're training them for careers, for any career in the future, because we hope that they're going to be equipped with computational thinking skills that will allow them to achieve whatever they want with their background in coding and computer science.
All right, so we are going to take a deep dive and give you an intro to CS First from Google. So just a little bit about CS First. This is a curriculum that started, I think, back in 2013. I was really lucky to be in on the early year or so as the CS First curriculum was rolling out. And it started as after-school programs, and it's really worked into a curriculum that can be used throughout the school at different levels. It's particularly designed for grades 4 through 8, but I would say that you can definitely go down to grades 3 and into high school with some of this content. What's great about it for teachers is you don't have to have computer science experience yourself. All of the lessons are there, and Tim will demo some of those in a moment. It's fun. It really connects to the interest of your students, and that's so important. We have lots of different interests, and so having that way that students can be inspired and engaged is really important, and it's free of charge. You can also get the kits. They will send you the actual kits of materials to use in your classroom. You can know that you have a lot of teacher tools to support your students. They can save their work. You have a dashboard so that you can see everything that your students are doing. And as I mentioned, you've got that free classroom kit. And to support that student engagement with those popular topics, you also have badges. So we all love badges, and students do too. So I'll let Tim go ahead and demo the dashboard for you.
So I'll just take us on a quick, brief tour of CS First, and just so you get an idea of what it looks like when you enter the website. So first off, you can sign in, and you can create an account for free. It's right here asking if you're a student or a teacher. I'm going to sign in as a teacher today because I think that's what we'll be interested in, seeing what that platform looks like. And of course, my computer is going to be a little laggy here, running quite a number of tabs all at the same time.
That's
Hopefully
okay. We had a question. So while you're
okay.
loading, one thing I did want to mention is the slide deck and all these resources will be available at the end of the week when they send out a recap of everything. So there is a question about applied digital skills. I don't know the answer of what all is integrated, but you will see from the dashboard that the applied digital skills curriculum, it's very similar to that. And so this is definitely a work in progress. And I think
Still trying to get in.
There we go.
Come on. I tested this just 15 minutes ago and it worked. I wonder what's going on. Well, let me talk a little bit about what I was hoping to pull up on my screen, which is the dashboard and the friendliness of the curriculum. When you dive into the dashboard, the first thing you'll see is whatever units are available. And Google does a really nice job of explaining kind of what content areas are targeted with the different activities, as well as which grade levels it might work best for. And then it also does a really good job of giving you everything you need in one spot. There's videos to walk you through each lesson. So if you've never taught a computer science lesson before, you can still use the lesson. And just honestly, I've even worked sometimes playing the videos directly for students. You have any worksheets or any activities all in one spot that you can copy. Google does a really good job of breaking it down for you and telling you how long or where something could fit. So for example, one of the things I was hoping to show you is it tells you exactly how many minutes and how to break down sessions so that you get a good idea of how something's going to work before you get into it. So you can get a good idea for how you want to break down the order of the things you want to do. Donna, was your screen working?
Yes.
Were you able to get in?
Yeah, so we did pull it up on my screen. So we're here, and this is the dashboard. You can see when you're signed in, you've got that teacher login, and we do have the dashboard here. So Tim, walk me through what I should do to
okay, so up at the top, it has curriculum. I would start by going to their curriculum. And then if you'll just scroll down, you can see one of the things they do is they break it down into what type of lessons you want to teach. If you've never taught before, you want to probably begin with their 1-hour lessons. And what I like here is immediately the focus is not just on computer science, it's focusing on how it can be integrated in other areas. So you see right off the bat, that very first activity really works well with language arts and characterization. Next to that, you have an interactive presentation, which honestly, with a little creativity, you can use this with science or social studies of any topic that your students are wanting to present. There's probably even ways to use it with language arts and math as well. You can keep scrolling down, please, Donna. And you can see as you go further down, they start to get into Hour of Code activities. So this is something that takes place once a year in the month of December, where we celebrate Computer Science Education Week. And each year there is an Hour of Code activity that has been added by CS First. And you can teach those lessons anytime throughout the year that you want. Again, those are typically formatted for short experiences. They will tell you between 1 to 2 hours. But where it really gets interesting is when you dive into the multi-day units. I've taught some of these multi-day units to after-school clubs and found them to be really engaging. I like that you can break them apart into larger projects. And if you'll click, for example, if you'll scroll down, no, actually don't scroll down. Go to the storytelling one. That is actually one of the projects I've used with students before. And I just want you to get an idea of how the lessons are broken down for you so that you can chunk the material and see how the sessions are designed. So if you'll keep scrolling down it. So for example, you see in day one, you're going to cover dialogue. And what I love about the way this is organized through CS First, you can see you've got a survey that you can start students with just to get an interest and an idea of what students' background knowledge is before you dive into the instruction. And then you can see they have several videos for you to play before students start even working on their own. And then you can see that when you get down to the end, you have your session wrap up, and then that leads you to your next steps. And you can see that this project is broken down into 7 different lessons. The way I've done it is each lesson typically is a week. So this could be something that you use in an after school club. And honestly, there's probably ways to integrate this into your classroom as well.
Right. So shall we take a look at also some examples? I thought I would just click on what I also love about this is you can get some examples of what students will be doing. So if you're interested in seeing how that will look after students do it, and then in the materials, there are all these wonderful lesson plans, posters, stickers, and certificates of completion too, which I think are really nice to be able to give that to your students, and you can download even contingency plans, like what happens when your computer crashes, Tim. So we've got contingency plans there. So good resources there. Anything else? Should we lesson?
I think that's all I had to mention here. I'm looking through some of the comments in our chat box here. Looking at, are there any plans to expand the CS First, the Google product here? And honestly, I don't know the answer to that question. Some of the things we will touch on later in the session have been expanded in that way. So if you're kind of looking for that larger piece, we will know more information. We will be able to give you additional information on that in just a minute.
Yes, and when you do go to your dashboard, we did have a question about the kits. When you go into your lessons, you will, I believe, at some point here have an option to order those materials, but I'll have to double check that. I can share that out before we close today. And if we could switch the screen back over for Tim, I'll let Tim move ahead with the other resources.
Okie doke. Okay, so you'll do this part, Donna? Is that correct?
Yeah.
Oh, no, I can do it if you like. Sorry. So coding in the classroom is more than just putting students in front of a screen, and it's more than just putting them into what we call block-based world of languages. One of the things that I think tends to get overlooked is the importance of giving students what we refer to as unplugged computer science activities. And especially at the level that I work with, and I think this works beyond our level as well, is thinking through the computer science before you start to actually work on the code is beneficial. And it helps really emphasize some of those critical thinking skills and a lot of the logical thinking that takes place with coding that helps us apply it to the ways that we integrate it into the classroom. So 3 reasons to work on Unplugged Activities. 1, it helps you understand the abstract. It tends to be that we sometimes think of this coding as this kind of hidden, invisible world that takes place inside of a computer. So Unplugged Activities allow us to kind of slow down the process and also relate it to physical objects. And here is where we can use things like music and pictures to also interact with and also explain what we're doing with the computer science. It's also an opportunity to put things in a familiar context, and then it also helps us create mental models. Just an example of an unplugged activity that I've had fun using with students in the past is when we first teach algorithmic thinking, and we still first want our youngest students in kindergarten and first grade to understand that when you give instructions to a computer, it has to be done in a specific and detailed way. We have them write down the steps to making a peanut butter and jelly sandwich. And we've had some actual really hilarious results from this because at first you don't realize how difficult it is to relay those instructions. But when the teacher's pretending to be a computer and is not filling in the blanks like we tend to do when we tend to tell someone or describe something to another person, we start to get across that notion that computers really are not smart in and of themselves. They're only going to do exactly what they're told. So just, an example of an activity that kind of demonstrates computer science and why it's important to give students something familiar when you're teaching those abstract thinking skills, such as algorithmic thinking. It also allows us to generalize that knowledge, and it's that opportunity to make connections. We also tend to focus on the language, and we focus on the specifics of what we're going to say with this unplugged activity. We're going to later on connect back to coding, and then ultimately it will also, at least in our school, be connected to another subject area as well. Another great reason to love unplugged activities is you don't have to have a computer. So especially if you're just getting into integrating coding or teaching coding to your students, and certain platforms might feel very overwhelming because it's very different than maybe the way you've been teaching. Going to that computer science that's unplugged helps you feel a little bit more comfortable with what it is you're teaching. And I also like that when we pull students away from the computer, we can focus primarily just on the problem solving skills and the principles that we're trying to teach. Now, there are in our slide here 3 different recommended sites that you can go to get some activities that you might want to look through, that you might want to teach from. CS First has some unplugged activities with it. There's also a CS Unplugged website that we're going to share, as well as CS Fundamentals Unplugged, which actually comes from another useful coding resource known as code.org. So let me go ahead and pull up the first one. This is CS First's Unplugged Activities, and they have 2 lessons in here. In the first one, you see what they've done a really good job of is you've got an introduction, you've got a career connection, and then from that career connection, they give you an unplugged activity that connects to the professional that they're introducing to the students. So in this example, students are learning to network a neighborhood. There's another example here of how to create your own emoji, send a secret message, as well as another one of their unplugged activities. So I'm just going to click on the network and neighborhood here. And you can see that what the students will actually do is they'll map out in the classroom the different ways that the internet sends and receives messages. And this is often something that students don't understand, is because they're not familiar with the structures of the internet and how it functions. So it's a really good way to introduce students to exactly what's going on in the background and the behind the scenes of how their computers work. There's also some other activities listed here as well. Another website to go to that might have more activities than what you see at the CS First website is called CS Unplugged. And again, everything here is computer science without a topic. When I come to this website, I usually just dive straight into their topics. And I was just going to take a minute to look through some of the topics that they have listed. For example, up here at the top, they have binary numbers, and they give you age suggestions, and they give you lessons. They even include integrations and programming challenges. They include things like error detection, an activity here called KidBots, and then another one which is similar to what we just saw called sorting networks. I've gone through several of these activities and used them with students, and really enjoy how they really bring the activity to life without being in front of a device. I feel like sometimes pulling students away from that device helps them focus more, and also and it gives me the opportunity to focus on the skill separate from the activity. So just a little shout out for this website, this resource. And then lastly, we have here CS Fundamentals Unplugged. This is through code.org. And this will give you an idea of how they have it mapped out. These actually take place in the individual courses that are offered through code.org. All this website does is it just lists all the opportunities for unplugged activities in each of the courses. So, for example, in course A, you have 3 activities that are unplugged: Happy Maps, Happy Loops, and the Big Event Junior. Then you've got the same for course B. Course C has 1, 2, 3, 4, And you'll notice that some of these activities are repeats from previous levels. So for example, Happy Loops is an unplugged activity specific to the skills related to course A. But then when you move on to course B, they take that same activity and they increase the level of understanding here. And so then now you're talking about getting loopy. So they're still teaching the same computer science skill of looping, but they've now specifically targeted the activity to the age level and the understanding that is tied along with the course that you're taking. So this is a good resource to look through. And if you're looking for unplugged activities.
And Mr. Cooper mentioned Barefoot Computing. I also use that website. Great resources.
Thank you very much. Awesome suggestion. Okay, now to the meat and potatoes of coding platforms. We in our area of K through 5, and even I've seen used in middle, and my son who's doing computer science in high school. Block-based coding is a great way to get started teaching students how to code or program on a computer. I've listed 3 platforms that I've had some familiarity with. There's lots of other platforms. The main reasons why we've chosen these today is probably because they're things that you can use free of charge. And all 3 of them are honestly very similar to one another. So let me just go ahead briefly and kind of compare and contrast these 3 resources. Number one, the one that I've got the most experience and the one that I feel is the most widely used is Scratch. It is a free programming that was actually designed specifically to teach students the architecture of how to program. This was developed in MIT through their Media Lab. And one of the things that I think that makes Scratch unique is their community. It emphasizes and encourages students to look at other people's projects, to see what other people are creating. And you're always allowed to remix and build something of your own from the code that someone else has created. For some people, there are concerns, though, over the social communities because there is some discomfort of what sort of things are being shared within their community. I do know that they have community guidelines and that they do follow those guidelines pretty strictly. But as always, whenever there's a social aspect to something, there's always some concern for that. I will also share another big reason why I like Scratch is the extensions. You can use Scratch in lots of different ways. So if you're growing your skills with coding, eventually you're going to start to look at other ways to use coding. And one of those is through physical computing. And so there are a lot of physical computing platforms that are designed to work with Scratch. So for example, if you've heard of the microbit, you can code the microbit through Scratch. We actually have Lego robots at our school, and you can use Scratch to code Lego robots. And I've also used something called a Makey with Scratch quite a bit as well. And now I have not played with it, but I've also seen recently that there are ways to start programming with artificial intelligence in Scratch. So you can start to introduce students to something that's quite complicated, artificial intelligence, in a very friendly platform through block-based coding. We also have Snap and MakeCode as well that are listed here. Snap is almost exactly like Scratch, except it takes away some of the social aspects. So I know some schools in our area prefer to use Snap for that reason. And then the last one listed there is MakeCode. Some things about MakeCode that might be different from the other 2 is you don't require a login. And the other thing to know kind of ahead of time is it's not a standalone language. It's actually only designed to use with certain products from Microsoft. So it's designed specifically to work with their arcade resources, as well as the BBC microbit. And then at our school, we actually use MakeCode inside of Minecraft education. So we do block-based coding in Minecraft worlds that we develop. I'll just briefly pull up these platforms so you can get an idea of what they look like. Here's Scratch, and you do need to sign into Scratch. Accounts are free. But once you log in, your platform will now change, and you'll see here you've got the social aspect. You can see what's happening and news, but then down below you have projects that Scratch is featured. You've got studios as well as other projects. So you'll get an idea here immediately that this is supposed to be an area where things are shared with one another. I'll just dive into my file folder, and you can see you can save your projects in here. And one of the things that we're working on doing at our school is creating studios within our school so that students can share projects within our school. And that's something that we're kind of working on getting up and running. Here's a project that I've been working on with some of our students during Related Arts, and they're developing their own kind of retro style arcade video games. And so you can see here, you get a preview screen and you get an idea of what the project looks like. I'm going to click see inside so you can see the editing environment. If you've never seen Scratch, I'll just walk you briefly through kind of how it's organized. And all of the block-based coding platforms I've seen all use this same basic formatting. Over on the left, I have my categories, and in Scratch, they're color-coded. So this is really helpful with those students that maybe are not even quite reading yet. You can even get them started just by telling which color to click on. And then the shapes of the blocks also help you identify them. So you can see the different types of blocks you have here that are separated by color. The individual blocks are over to the right from that. In the middle, you have your work platform. So this is where you actually develop your algorithms and your sequences. On the right, you have your preview screen. Down below, you have what are called your sprites. These are your characters that you can manipulate. One of the nice things about Scratch is it gives you characters that are already in a library, but you can also create your own or even upload characters that you've made in a different graphic editing environment. And then over on the right, you have your stages, so you can change the background. In this project, we're teaching students how to use the forever loop and if-then conditionals so that we can use keyboard control. So if I click the green flag, the character can actually move left or right. And so we're using something called costume switching to give a realistic look to how the character moves. This is an unfinished project. We'll be actually finishing this up next week, and the students will be learning how to use variables and some randomization to have stars fall. And then the object will be to get their character to collect the stars before they hit the ground.
That's great. Tim, we did have a question, and I guess
Yes.
we'll be wrapping up in a moment, but we were talking on the comments about sharing options. So you were mentioning which platform is more collaborative, but CS First in the classroom settings, I don't believe that there is sharing options for students. Can you clarify that?
I've not shared the projects in CS First, so I don't think you can. If you can, that would be new to me. So it'd be something that maybe they've updated it. But in the past, when I've used CS First, I've used their classroom, and that allows the teacher to see what each student is developing, but the students can't share between the students, so that you don't have that same level of collaboration and that same level of ability to share with one another what you're building.
Yeah, but we will definitely take those notes and pass that on to the team to find out more if there are other enhancements coming.
And I'll just briefly talk about Snap. Snap is developed through Berkeley, and you'll notice immediately that the environment's a little more advanced. I know that my high schooler's been using Snap in his high school computer science program, and they use it as kind of an intermediate step into getting into text-based coding, such as, like, I think, for example, they're going to be doing Python and Java. And you'll see you got the same idea of the blocks, and the blocks actually typically even have the same colors. So you're not relearning. If you've learned in Scratch, you can transition those skills over to Snap pretty easily. I will say one main feature of Snap that I've seen that I personally haven't explored too much is you can create your own blocks in Snap. So when you're getting to some of the more advanced coding techniques that go beyond what Scratch is capable of doing, you can do some pretty complicated coding in Snap because it has that ability to grow. And then here is MakeCode. Again, you can see it's designed for their 3 platforms. When you click one of their platforms, it now gives you blocks specific to that tool. So the blocks you get when you're in the microbit version of MakeCode are different from the blocks you get when you're in the Minecraft or the arcade version. So I'm just going to open this up for just a quick second. And again, you'll see it's the same concept. You've got your blocks in the middle, and you've got your preview screen over here on the left, and you've got your editing environment, your kind of your sheet that you put code down on your right. One thing that I do like, particularly here with the microbit version of MakeCode, is you get a virtual microbit, so you can test all your projects for real in a virtual world before you export them or save them to the actual microbit board that you will use for your kind of your projects that you're building your real kind of computer board pieces there. So that's just a real quick look at block-based coding platforms. Any questions that kind of popped up, Donna?
Yeah, I think we've been answering them as we've gone along. So maybe we'll just share out this last set of resources, just let people know there's more, right?
Yes, yes. So just some things that I felt like were worth sharing is once you go through and dive into this world of coding, it's kind of like you can just keep going with what you're learning. You can keep building and developing your tools as an educator. So one of the things I really like about computer science is there's so many different things you can do once you get over the initial kind of fears. So, for example, at our school, we do a lot with Lego robots as well. And the computer science that's built into building our Lego robots kits is really kind of been neat and interesting to look for ways to develop immersion. And Lego Education has a number of platforms that you can choose from. I know that our school is using actually 4 of their kits. They have a WeDo 2.0, which is designed for your younger learners. The sad news about WeDo is it's no longer being made or sold by Lego. They now have a newer kit called Spike Essential, which is actually an improvement on WeDo. And so we're now learning how to kind of update some of our curriculum for the newer platforms that are being supported by Lego Education. We also have the trusty Mindstorms robots. We have the EV3, and then also they have something called the Spike Prime, which is a more advanced version of the Spike Essential. Typically, those robot kits work all the way up through middle school, and there are probably ways to continue using them in high school if you so chose to do that. I really like the creativity that takes place when you look at Minecraft Education. This is a resource I think sometimes gets overlooked. It can be used in so many different ways. You don't have to specifically focus on coding or computer science, but there are some great ways to use coding through MakeCode, which is built into Minecraft Education. We put these in our resources because these are not free. So these are things that you'll have to have some funding to get up and running. And then I also really enjoyed learning ways to use the microbit. Number one, this is a very inexpensive programming board that can get students interested in what I call hands-on computing. It starts to pull the programming off of the computer, and now it can interact and create like everyday inventions with their microbit. And they sell them fairly inexpensively, and they can be used in lots of different ways. It's not a one-trick pony. So investing in teaching your students how to use a microbit can pay off in lots of different ways.
Well, thank you, Tim. We have additional resources, of course. You can also run Linux on your Chromebooks, so we will share out the link to that later. But I know that's been a lot, and thank you so much for Tim for sharing all of these resources. We have even more, so please reach out if there are additional questions, and if you've got resources to share, please use the comments to share those. And so in wrapping up, I just wondered if there were any additional questions.
Thanks for having me, Donna.
Well, thank you so much, Tim, for coming. So we know we need another session for additional resources, but please reach out and these resources will be shared out with you later. Thank you so much.